Okay, so today's unit is the start of a new unit. We're still in linear relationships, but we're in the multiple representations. We're really going to continue to bring in our graphs, our tables, our word problems, but we're bringing in one other component, equations. Okay, so that's what we're doing today. We're doing equations, slope-intercept form from graphs. Okay, so if you look right here, y equals mx plus b. That is an equation that is written in slope-intercept form. This equation right here is what we call like a parent equation. It's kind of like an equation template or an equation format. When we write our equation, it's going to follow this same format. Okay? So first of all, you have your x and y values. Those are going to stay as x and y when we write our equation. Because remember when we were talking about tables, what you do to x gives you your y value, right? So what I do to my x over here gives me my y value. But we have to replace certain other variables with information that pertains to a graph. So the first variable that we need to identify is the variable m. Does anybody remember from us talking a little bit in our last unit, what does m represent? Slope. You remember I told you in the last unit, m represents slope, and it would show up in this unit. Ta-da! There it is. M represents slope. Now, the other variable we have is this b. We can even include the little plus b here. Well, if this is called slope-intercept form, and we have the slope, what do you think the variable b represents? Y-intercept. You got it. The rate of change would be your slope. The b would be like a starting point sometimes, or it's just the constant. It is also the point where the graph crosses the y-axis, y-intercept. So we're building on what we learned in our last unit about slope and y-intercept. And we're taking that knowledge and we're putting it into an equation. Okay? So first, let's practice. I just want to practice writing the equation. If I give you the slope, I give you the y-intercept, can you put it in the equation? All right, so let's look at our first example here. I tell you that the slope is 1/3. I tell you that the y-intercept is 0,4. If it crosses the graph at 0,4, what is the value of the y-intercept? It's just the 4. It's that y value. Y-intercept is the y value where it crosses the y-axis. All right, so literally all we're going to do is we're going to plug in the 1/3 for m, the 4 for b. So when we write our equation, y equals, m means slope, so what was my slope? 1/3. We keep the x. And what's my y-intercept? Is it a positive 4 or negative 4? So there's my plus 4. And that's it. That's my equation. 1/3, that matches the slope. Positive 4 matches the y-intercept. And we're done. We have our equation. But there's so much I can tell from this equation. First of all, my slope is the line, if I graph points, would the line be going up or down? Up, how do you know? It's positive. Is this proportional? Okay, well first, what does it mean to be proportional? The graph has to do what? Go through the origin. And what's the ordered pair of the origin? Well, that crosses at 0,4. Does that cross at 0,0? So is that proportional? Nope. It's linear, it's going to be a straight line, but it's not proportional. So I know this is going to be a graph somewhere on my coordinate plane that's a straight line that goes up and it does not go through the origin. All of that just from that one equation. All right, let's look at the next one. Again, my slope, negative 7/2. So what's happening here? He says going down. Do you agree or disagree? Agree, justify it. Defend your answer. Why do you agree? The y is a negative? The slope, yes. The slope is negative, so we know that has to be a line that goes downward. The y-intercept is -5. So what does that -5 mean? -5, but what does it mean for a graph? What's happening at 0, -5? The line intersects right there. It crosses right there. All right, does anybody feel brave, think they can put all that together in an equation? Probably. Okay, go for it. Tell me what to write. Hold on. He's going to do it.
Y equals negative 7/2 minus, is it minus -5 or -5?
Just -5.
Okay.
But there's something missing. Look at this one and this one. What's missing? X. You just forgot the little x right there. -7/2 x minus 5. And again, I'll color code it so you can see how our pieces match up. So literally, all we did is we substituted in information we were given into the equation to write an equation. How do we feel about that? Give me thumbs up, thumbs sideways, thumbs down. Thumbs up, thumbs sideways, thumbs down. Okay? Online people, you have to participate too. Thumbs up, thumbs sideways, thumbs down. I see one thumb. 2, 3 thumbs. 4, 5, 6 thumbs, 7 thumbs. I need one more thumb. All right, okay. Want to make sure. Do we have any questions before we go on? All right. Now let's put this together with some different examples. Let's open the page. Notice I printed these in color for you so that way you can have some color-coded notes, because each equation in the equation bubble matches the same color line. So let's talk about these. The green line. The rise and the run, we see the rise is 3, the run is 7, so the slope is 3/7. Where does this cross the y-axis? At +8, right here is +8, so here we have our +8. Just kind of like what we did before, except we can see now how that relates on the graph. But look at the purple one. What's different in this purple equation that's different from this green equation? The line does, but what about you're right, that's a big difference. But what about if I was just looking at the equations? I didn't have the graphs. What's different about the equations? There's no y-intercept showing. There's a y-intercept. We know from the graph there is. It's just not showing. And let me show you what they did. If I were to rewrite this with the y-intercept, y is equal to 1/2 x, because we know that's the slope. Well, where did it cross? So that would be +0, right? Well, if I have like 3 + 0, do I really need to say +0? Do I really need this +0? So what they do is they just drop it. So they just take it off, and you have y equals 1/2 x. They're both still technically correct, but you're going to see it written this way. So if you were doing your work and you wrote +0, would you know that this is the same thing? That's what you have to know, okay? All they did is just drop it off. That's a better way to write it. Kind of like we don't say 3 times x, we say 3x. Okay? And then the last two, the blue and the red, those are like some special cases. Well, look at the blue. What's missing in the blue from these? The slope is missing. Well, let's look at the graph and see if is it really missing or is it just not showing? Well, what kind of slope do we know horizontal lines have? 0. And remember, if you forgot, you could kind of make a little z for 0. Well, let's rewrite the equation and put in our 0 slope. So if I rewrote it, y equals 0x minus 4. Well, that means 0 times x, right? 0 times the value of x. Well, what's 0 times anything?
0.
0. Do I need to keep it if it's 0?
No.
So they just dropped it. Y is equal to negative 4. So all they did was just drop it out. Took it away, because I don't need it. But then look what that really means for my line. No matter where, remember this was my original line right here. I'm going to make it a little bit bigger so we can see it. No matter where I put my point on that line, my y value was always going to be negative 4. If I drew my point right here, what's that ordered pair? 1, negative 4. What if I drew it right there? What's that ordered pair? Negative 2, negative 4. Do you see how no matter where I put it, my y value is always going to be negative 4? Y equals negative 4. It's got a 0 slope. Now, what kind of slope does vertical lines have? Undefined. So it's undefined, so I can't define it by using slope-intercept. So it's a special case. And we're going to use the same logic that we did here. Every x value is going to be negative 7. If I put my point right there on the line, what is that ordered pair? Negative 7 over negative 7 up 1. What about right here? Over negative 7, down how many? Negative 2. Well, what about if I went right there? What's that going to be? Negative 7, and I'd say about, we're going to estimate negative 5. But do you see how every x value is negative 7? So these two are the special cases. They pop up every now and then when we're talking about it. Most of the time you'll be asked to create equations from lines that either go through the origin or don't go through the origin. Okay, that either have a positive slope or a negative slope. Okay? Are y'all ready to do it? Are y'all ready to work on this? Think we can write equations from a graph?
Yeah.
I bet you we can. Let's go. Turn the page. It's slope-intercept form. So naturally, I need to know my slope. I need to know my y-intercept. How do we find slope from a graph? Rise over run. M is equal to the change in y over the change in x, which on a graph, we just call that rise over run. So M is equal to, well, first of all, what kind of slope is this? Look at the graph. Negative, how do we know? This is going down. So I just write a little negative symbol instead of writing it out. I'm tired of writing it out now. We know what that means, right? It's negative. All right, so I better put my negative here before I forget. We don't want to forget. All right, did this graph give us two pretty points? Yes, it did. It gave us a pretty point here at 4, 5, and at 0, 8. So what do I need to do to find slope of this line? I have to count rise over run, but in order to do that, what do I need to do? We don't need cell phones right now. Do I just start counting 1, 2, 3, 4, 5, 6, like that? No, what do I need to do? Count the rise, count the run, and what do I draw to help me do that? Our triangle. We have to draw our triangle. So that way we can count our vertical change and our horizontal change. Change in y, vertical. How much did this go up? 3. So we're at a 3. Now I need to do the run. How much did it go over? 4. So there's my 4. So what's my slope? Negative 3 over 4, 3/4, negative. Can I simplify that? Nope. So I'm just going to put a bubble around it. I'm not going to box it because it's not my final answer. It's just I know it's important. I need to use it to make my equation. All right, next, y-intercept, B. Where does this line cross the y-axis? Right here, positive 8. So what is the y-intercept here? 8, positive 8. All right, let's write our equation. Our equation is, everybody, y equals negative 3/4 x plus 8 or minus 8? Plus 8. Why is it plus 8? You're right. Because this is a positive 8. You have to know that because if this was a test question, don't you think you'd have the same thing but minus 8? Yeah, they'd try to trick you. There's our equation. We're done. You already know how to do all the work up here. Oops, I should have bubbled this because I know that's important. I need to use. You already know how to do the work. Now you're just plugging it into the equation that y equals mx plus b. Remember, y equals mx plus b. Probably should have wrote that in blue so it matched. Y equals mx plus b. That is our equation format. We use that format to find that equation. All right, let's look at the next one. Think we're ready for this one? Yeah? It's kicked up just a little notch. All right. First of all, what type of slope is this? How do you know? It's going up. All right, so it's a positive slope. I don't have to worry about any signs. How do we find slope? Rise over run. So change in y over change in x. Rise over run. Now, you may be like, why does she write this every time? I do it because if I write it, I say it to myself and I remember it. You don't have to raise your hand or nothing, but think back to when you took the test. Was there ever a time you were so focused that you just went blank and you're like, oh my God, is it X first? Is it Y first? Which one? If you write it and say it to yourself each time, it forms a habit and you start remembering it. It helps you recall that information. All right, so M is equal to, I have to find my rise. Do I have 2 pretty points? Yes. All right, let's draw our triangle. All right, what's my rise? How far do I go up? 6. I like that. And how far do I go over my run? 4. Is that my slope? 6 over 4? No, why not? I counted rise and run. Simplify. Very good. Always simplify. What can I divide by? 2. What's 6 divided by 2? 3. And 4 divided by 2? So my slope is a positive 3/2. Not 3/2. 3/2. All right, now we need to figure out that pesky y-intercept. But, uh-oh. Oh gosh. The line doesn't cross the y-axis. What do you think we gotta do? Well, do you see these little arrows? What do those little arrows mean? The direction of the line. Does it mean it can keep going? Lines go forever. So can I just draw that line a little bit longer? Let's do that. Let's see. I have a ruler. I know you don't. But if I were to draw that and continue it out, where does it cross that y-axis now? It crosses at -1. Do we have what we need? All right, who wants to be brave and put this into an equation? Yes, sir.
Y equals 3/10
Do y'all agree? Y equals 3 over 2, so positive slope. Negative 1, are you sure it's negative 1, not plus 1? Yes. But this says y equals mx plus b. Why is this negative? Because the y-intercept is negative 1, yes. Good. All right. Those of you on campus, you can go ahead and glue this into your spiral. Those of you online, you can either print it and glue it into your spiral or keep it saved someplace where you can reference it.